Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss the 19 ECEB 301 Analog and Digital Communication subject under the topic Comparison of various pulse communication techniques such as pulse amplitude modulation, pulse width modulation, pulse position modulation. So if you see my previous YouTube videos, you may have some knowledge about what is meant by communication and what are all the types of communication and the use of amplitude modulation. Now we will going to see the comparison of various pulse communication techniques. So the first one and the important one is pulse amplitude modulation. If you see this figure, by varying the amplitude of pulses of the carrier signal in proportion to the instantaneous value of the analog signal. Pulse amplitude modulation is used in the popular technology of Ethernet communication standard. So if you see the figure, the top blue color indicates the carrier pulses trained used for modulation, and the second one is the proper sine wave of analog signal for modulating, and the third brown color indicates the pulse amplitude modulation. If you see here, only the amplitudes are only changing, the remaining frequency and phase are all constants. Pulse width modulation, by varying the width of the pulses of the carrier signal in proportion to the instantaneous value of the analog signal, that is the message signal. Here the width of the pulses varies, but the amplitude of the pulses remain constants. Amplitude limiters are used to make amplitude constant. So here only the width only changing, the remaining factors amplitude and frequency are all constants. Pulse position modulation, as the name indicates, by varying the position of the pulses of the carrier signal in proportion to the instantaneous value of the input message of analog signal. Pulse position modulation is done in accordance with the pulse width modulated signal. Each trailing of pulse width modulated signal becomes starting point of pulses in the PPM. So here the process is same as pulse width modulation, only thing the position alone is changing. So if you see the figure, you can thoroughly understood. Now we will go to the comparison. Parameters, type of carrier. So in pulse amplitude, we are using train of pulses as the carrier. In pulse width modulation, we use the train of pulses of the carrier. Then same as in pulse position modulation, we use train of pulses as the carrier. Then variable characteristics of pulse carrier. In PAM, amplitude is varying. In PWM, width is varying. In PPM, position is varying. The next third one, bandwidth requirement compared to PAM, PWM, PPM. PWM, PPM are high bandwidth compared to a PAM, and PAM will possesses the lower bandwidth. Next, noise immunity property. PAM having low noise immunity power, PWM and PPM having the high noise immunity value. Information contained in this modulation is, here PAM is amplitude variation, in PWM it is width variations, in PPM it is position variations, that is only the position of the input signal is varying. Power efficiency, that is signal to noise ratio. PPM having higher value, PW having somewhat moderate value, and PAM having a lower value. Transmitted power, in PAM it varies with amplitude of pulses, in PWM it varies with variation in widths, in PPM the parameters are remaining constants. Next, need to transmit synchronization pulses. PAM it's not needed, PPM is also needed, but PWM it is needed, because in PPM the position is allowed to change, so we have to synchronize the transmitter and the receiver. Bandwidth depends on, in PAM bandwidth depends on the width of the pulses. In PPM bandwidth depends on rise time of the pulses. In PWM the bandwidth depends on rise time of the pulses. Transmitted power, instantaneous transmitter power varies with the amplitude of the pulses in PAM. Instantaneous transmitter power varies with the amplitude and width of the pulses in PWM. Instantaneous transmitted power remains constant with the width of the pulses in PPM. The complexity of generation and deduction. Since PAM and PPM having the complex in deduction and generation, PWM is somewhat simpler. Similarity with other modulation techniques, PAM is similar to AM, PWM is similar to FM, then PPM is similar to phase modulation. So the general key difference between PAM, PWM and PPM are a factor that generates a key difference between PAM, PWM and PPM is that in PAM, amplitude of the pulses shows proportionality with the amplitude of message signal. In PWM, width of the pulses shows proportionality with the amplitude of the message signal, whereas in PPM, the position of the pulse is proportional to the amplitude of analog modulating signal. PAM technique shows low immunity towards the noise, as against PWM and PPM has low noise interference factor because the noise immunity is higher. In PAM and PWM techniques, transmitter and receiver synchronization is not required, but in PPM technique, it needs synchronization between transmitter and receiver section. The SNR is low in case of pulse amplitude modulated signals, while it is moderate in case of pulse width modulated signal and highest in case of pulse position modulated signals. In the transmitter power, in case of PAM and PWM, it is variable due to variations in amplitude and width respectively. However, it is constant in case of PPM because both amplitude and width are constant in case of PPM. In PAM, transmission channel bandwidth relies on the pulse width, but in case of PWM and PPM, rise time of the pulse is a factor on which the transmission channel bandwidth depends. As the position of the pulse is changed in PPM, therefore it requires synchronization pulses, while both PAM and PWM doesn't need synchronization pulses. In PAM, PWM, PPM, it shows similarity in implementation with AM, FM and PM respectively. The bandwidth requirement is low in case of PM, but it is comparatively high in case of PWM and PPM. So in this YouTube video, I am discussed the important terminologies of PAM, PPM and PWM and some comparisons of parameters included in PAM, PPM and PWM. So thank you for watching my video. Next YouTube video, I will take the new topic for discussion. Thank you.